We are now going to look at two examples for the divide and conquer algorithm. The first being a very classic, famous example, which is merge sort. Before going into the actual divide and conquer part, let's look at some context. So merge sort, as the name suggests, is a sorting algorithm. Why do we need this when we already have so many other sorts? We have bubble sort, insertion sort, selection sort, so many. The thing is, most of the traditional sorting algorithms, the time complexity is order of n squared, where n is the size of the array. And as you know, as your array size increases, n square is going to become very expensive. So is it possible to do better? And if yes, is it possible to do better using divide and conquer? This is the question people had. So what if instead of one big array, you had two halves, two sub arrays, left and right, for instance, and supposing that left and right were individually already sorted, like the elements of the left array within themselves they are sorted, the elements of the right array within themselves they are sorted. Now you just need to put these two together in such a way that the combined array is sorted. So if that was the case given to you, then there is a technique using linear traversal by which you can combine both and result in a sorted array within order of n. So, and how is that linear traversal and combination done? We are going to look at it shortly. So the question is, can we use this to come up with a sorting algorithm which costs less than n squared? So first of all, these halves which we divide at every step, where does the division stop? Let's say it stops at unit size and you return those arrays. How do you combine them back? Combine the two sorted halves back to get one fully sorted array. And how do you accomplish all of this in less than n square? So these were some of the questions in mind when the merge sort algorithm was developed. So with that context, we will now look at the algorithm. So here the algorithm is stated in a very formal way. I'm going to explain it in simple words. You're given an array, you want to sort it, and hopefully in less time than n squared. That's the idea. So what you do is, you take the array, you divide it into two halves, left and right. You divide it roughly at the midpoint. Again you take each half, you keep dividing it recursively until the subarray has only one element. That's your base case. So at your base case, it's just one element, so you return each of those elements. Then you will combine those two elements in the correct order, the smaller one followed by the greater one. So you have a sorted array of size 2. Similarly, you will do that with the right subarray, you have size 2. Now you will combine those two arrays of size 2 to form an array of size 4. Again, you will combine two arrays of size 4 to form an array of size 8, and so on. So at every step, you will combine two arrays of size, let's say x and x respectively, to get an array of size 2x. You keep doing this repeatedly until you get back your original array of size n. So I'll repeat that. It's very simple. You just divide an array into half. You're going to sort the left half, sort the right half, and then combine them back together using a linear traversal. Now how is the left half and right half sorted? Again they are divided into two individual bunches, two individual subarrays. And how is it combined? Using something called a linear traversal, which we will look at. So I'll give you guys an example and I think it will be more clear. So if you look at the first picture on the slide, your input array is 19, 17, 22, 21, 24, 30. So this is, as you can see, an unsorted array of size 6 if I'm not wrong. So when you apply merge sort on this, the first thing that happens is this gets split into two halves of 3 elements each. 19, 17, 22 is one subarray, 21, 24, 30 is one subarray, and this is a divide step. Again, this array, if you take it, it has size 3. Our base case is when the array is of size 1. This is not the base case, so again you divide. It gets divided into 19, 17 on one hand and 22 on the other hand. So if you see here, 22 is an array of unit size, so it's the base case. So whenever it is needed, it will just be returned as such. No operations are going to be performed here. This, on the other hand, is an array of size 2. It is further split into 19 and 17. So this is another divide step. Now these two are arrays of unit size. You've reached the base case. there is no more divide to do here. The conquer step is going to simply return the two elements as such. So all these were divide. Now these two arrows over here represent the conquer step. Now having been conquered, you received two elements 19 and 17. They will be combined in the correct order to result in 17 and 19. So here you have one partially sorted subarray, and this one again is a base case, so it is another partially sorted subarray. So the conquer step happens and this is returned. Now these two are again combined, so you have 17, 19, 22, which is one partially sorted subarray of size 3. Coming to this side, you had again a subarray of size 3 unsorted. It is divided into 21, 24 on one hand and 30 on the other hand. 21, 24 being an array of size 2 again gets divided into two arrays of size 1 respectively. Now that the base case of an array of unit size has been reached, the conquer step takes place. The elements are returned as such. They are combined now in the correct order. So you have 21, 24, which is a partially sorted subarray of size 2. And then this being another base case, it is conquered or returned. So you have 30, which is another partially sorted subarray of size 1. These two are again combined to give you 21, 24, 30. So if you look at it now at this stage, you have two partially sorted subarrays of size 3 respectively. Now we move to the second image. You take those two, again those were the result of the previous step, those are returned, and now the next step is to combine them, of course. So we perform what is known as a linear traversal, which we are going to look at, and once that traversal is performed, both the arrays are combined in this order: 17, 19, 21, 22, 24, 30, which is the final sorted array. So this is how your divide and conquer works, and let me reiterate that I have not explained the combine step yet. I am going to do that in the next slide. But to give you an overview, at every step the array is broken down into half, half, half. When it reaches the base case unit size, it is returned. So whenever things are returned, whenever the conquer step happens and the the number is returned as such, the combine step comes into play, and when the combine step is done, you have a partially sorted subarray of a specific size. Now at every step you keep combining two such partially sorted subarrays until you finally get your fully sorted array.